All right, we are in section 9.2, characteristics of quadratic functions. Now remember when we graphed earlier in the book that when we talked about an x-intercept, that's the value of x when y is equal to 0. All right, so a 0 of a function, when we're talking about quadratics, is an x value that makes the function equal to 0. All right, so get this in your notes. A 0 of a function is the value of x that would make the function equal to 0. In other words, the y value would be 0 for that value of x. Okay, now a quadratic function may have 1, 2, or it may have no zeros, just depending on how the parabola is placed. And by the way, as we go through this video, I might go a little fast. So if I go fast, just feel free to pause it. So example number 1, finding zeros of a quadratic function from the graph. So here we have the graph of y equals x squared plus 8x plus 16. And you can see here that the 0 is right here. Here is the value of x when y is 0. Because when y is 0, you're right on the x-axis. Right? So the 0 of this function is found where x is equal to -4. All right? And we could verify that by substituting -4 in place of x in the function. And by doing that, we would get the value y equals 0. So it does check. Now notice that if a parabola has only one 0, that means that the 0 is going to be the x-coordinate of the vertex. Okay, so if a parabola only has one 0, that means the vertex of the parabola is hitting on the x-axis. Okay, look at this graph. Here's the graph of y equals x squared minus 2x minus 3. Notice that this graph has two zeros. It's hitting at two different points on the x-axis. All right, those appear to be at -1 and at +3. Okay, again, we could check those by substituting -1 and +3 independently in place of x. And each time we would get 0 for the value of y. So those are the zeros. All right, let's look at this one. What are the zeros of this graph? Well, if you said there are no zeros, you're correct. This graph is not hitting anywhere on the x-axis. So this function has no zeros. Example 4. Here's the graph of x squared minus 6x plus 9. How many zeros does this one have? That's right, it has 1. What's the value of that 0? That's correct, it's 3. And let's check it. 3 squared minus 6 times 3 plus 9 is equal to 0. All right, so those are examples on zeros of functions. Now let's talk about axis of symmetry. Now, there's an imaginary vertical line that you can use to divide a parabola into two symmetrical halves, and we call that the axis of symmetry. Now, the axis of symmetry will always pass through the vertex of the parabola, in other words, the highest or lowest point. And sometimes you can use zeros to find the axis of symmetry. All right, so here's an example of a parabola that has one 0. And the axis of symmetry is going to be right where x is equal to 3, because that's the location of the vertex. The vertex is where x equals 3, y equals 0. All right, so that vertical imaginary line, okay, is going to be the value x equals 3. Remember that in chapter 5 when we graphed lines that were vertical? Those were lines that were x equaled something. Here we have a function that has two zeros. All right, so look where that axis of symmetry is located. It's located halfway between -4 and 0. Those are the values of x that are on the x-axis. Okay, so it's located at -2. See that? All right, so let's find the axis of symmetry for these. For A, okay, the equation of the line is going to be x equals what for the axis of symmetry? Well, let's look at the vertex. The vertex is at x equals -1. So the axis of symmetry is located at -1. Okay, let's look at the second one. The second one, the axis of symmetry should be halfway between these two zeros. So that's why we're told here to find the average. Because when you find the average, that's what you're doing. You're finding the point halfway between two numbers, if you're averaging two numbers. So here, the axis of symmetry is going to be right along here. It looks like it's going to be at 1, 2, like 2.5. Okay? Axis of symmetry is at 2.5. Okay? How are you doing? Is this making sense? Well, I hope so. All right, let's find the axis of symmetry for A and B. Okay, for A, it's going to be -3 because the vertex is -3, 0. For B, there are two zeros. Let's find the halfway point. Halfway between -2 and +4. What'd you get? Yeah, it looks like 1, doesn't it? -2 plus 4 divided by 2 is 1. Yes, halfway between, right here. Okay, so x equals 1. Now, if a function has no zeros, or they are difficult to identify from a graph, then there's a formula that we can use to find the axis of symmetry. And this formula will work for all quadratic functions. Okay, so here's the formula. Okay, x is going to equal the opposite of b over 2 times a. All right, so for your quadratic function, of course, it has to be in standard form, so you know exactly what a, b, and c equal. If you take b, the coefficient of the x term, and you take a, coefficient of the x squared term, right? Put them into this formula, that will give you the axis of symmetry. So here's an example. Finding the axis of symmetry for y equals 2x squared plus 4x plus 5. b is 4, a is 2, so 4 over 2 times 2 would be 4 over 4, which is 1, and then take the opposite. So the axis of symmetry for this equation, this function, would be at x equals -1. That also would tell us that there's going to be the vertex at that point. Okay, let's find the axis of symmetry for this graph. Okay, so let's use the formula that we just saw. Let's use b and a. So b is 10, a is -3. So the axis of symmetry is going to equal x equals -b over 2 times a. That's going to be 10 over 2 times -3, which is 10 over -6. And then negative and a negative is going to cancel out. So 10 over 6, but that reduces to 5/3. Does that make sense? Okay, you try this one. You can pause the video if you'd like. Okay, so here are the values of a and b. Let's substitute it into the formula. X equals -b over 2a. So the axis of symmetry is x equals -1/4. Thank you very much for listening. You've been a great audience.